Hi everyone, my name is Sumit Kumar and I'm a product manager at Snowflake AI/ML team. Today, I am thrilled to announce the general availability of Snowflake ML online inference and the online feature store. You can now serve models for real-time use cases such as fraud detection, real-time personalization, achieving sub 100 millisecond predictions directly where your data lives. To make Snowflake the most performant and secure platform for real-time serving, we are focused on four key tenets. Number one, zero friction deployment. A data scientist should be able to deploy a production-ready model in minutes, not hours or days. Number two, intelligent and cost-effective. The system should automatically optimize for performance and cost, scaling resources intelligently without user intervention. Whether it's a quiet Tuesday or Black Friday, Snowflake automatically scales your inference containers to handle any spike. Number three, this is my personal favorite, which is fully observable. Provide real-time actionable insights into both the operational health and the ML performance of every deployed model. By simply setting a flag called auto capture, Snowflake logs every single input and output for auditing and monitoring. And number four, which comes with every launched Snowflake feature, which is enterprise grade security and governance. Now, to see all of this in action, let's walk through a live fraud detection demo. We start in Snowsight. Essentially, we want to build a fraud detection model so that we can showcase our newly launched capabilities, which is online feature store and real-time inference. Now, rather than using or starting from scratch, we will use Cortex code. Let me start with a notebook. From the right panel, I open Cortex code and give it a prompt. I'm essentially saying I want to train a fraud detection model which should help me predict credit card fraud in real time. The goal is to approve or decline credit card transactions in under 100 milliseconds. And I need a comprehensive notebook that implements a real-time credit card fraud detection system. Attaching the fraud detection data set and demo script for reference. So let me attach both of those. So this is a demo script, and then this is the data set. The beauty is Cortex code will help us generate an end-to-end notebook with all the key steps, right from defining the features, training a model, deploying a model to SPCS, and so on. While we let it do it, it takes good 3 to 5 minutes to keep everything up and running. And while it does that, let me show you another notebook which I created, and we will come back to this notebook in a bit. So again, I used Cortex code to generate this notebook earlier. As you can see, it created all of it on its own. It helped me create a warehouse, the database where I have the right permissions to run a model, and so on. It looked at the data set to understand which features are more important. Did feature engineering to kind of compute the features which are important for model training. Did the online feature store integration. Online feature store is important because it helps create a ultra low latency feature lookup that can be used during real-time inference. Again, as you can see, the pre-computed features are loaded. In our case, we are setting an online target lag of 30 seconds, which essentially means that Snowflake should be able to refresh my data every 30 seconds. It tests online feature retrieval. The average latency we see is around 14 milliseconds per lookup. And then it tries to register a model. It registers the model. Then it deploys the model to SPCS for real-time inference. It creates a compute pool called fraud detection pool with min and max node. And then deploys the model for real-time inference. As you can see in this case, you can, set min and max instance, and depending on the load, Snowflake will automatically increase, decrease the instances. And then the other important thing to note here is you can also set auto capture equal to true, which will essentially log all your inference requests that you can use later on for triage or observability. As you can see, the service is created successfully. This is the endpoint URL, which you can call externally as well from any application. It quickly tests real-time inference. Now here comes the key part. I'm trying to mimic a bot attack by essentially firing thousands of transactions of stolen cards just to see how does this system react under pressure. Are we able to maintain a latency of 100 milliseconds under heavy load? Are we able to auto scale up and down? Are we capturing all of the requests and so on? In this cell, you can see we are generating the bot attack transactions. I'm sending 5,000 synthetic transactions. And here we see the service is able to scale up and down under load. And these are results. The bot attack simulation is complete. The total transactions were 5,000. Total time was 461 seconds. And the average latency was around 43 milliseconds. We can also see the P95 and 99. Again, all of this under less than 50 milliseconds. We also checked that auto scaling has occurred. It started with one instance, and depending on the load, it was able to go to max 4 instances, which is what we defined at the beginning. And then we also have auto capture logs and so on. In this section, we try to visualize this bot attack just to get a sense of the latency, the transactions, and so on. And again, you can see the latency profile here. Everything within less than 100 milliseconds, which was our target. A quick summary. What we built. We loaded 66,000 plus fraud detection transactions from a workspace file, trained an XGBoost binary classifier with class imbalance handling, registered the model in Snowflake model registry, then deployed it to SPCS for real-time inference, and then also enabled HTTP ingress endpoints for external access. The beauty is I even asked Cortex to deploy this as a Streamlit app so that I can view it in real time. So let me go to Streamlit and show it to you guys. So this was the app that it deployed. I'll also try to use this Streamlit app to quickly run the bot attack. So let me launch attack. I'll increase this to 2,000 transactions. So the key part is even with this number of transaction, the system is able to automatically scale to handle this load. As you can see, and all of this is happening dynamically. So the simulation is done. Now let's look at the metric dashboard. It clearly shows the total number of transactions, the total time it took, the average latency, and so on. Again, and then we also have auto capture data. We can query any data, what was the request response, and so on. Auto scaling configuration. The feature store is also, we can also quickly test the online feature retrieval and the latency that we are seeing there. Again, for online lookup, we are seeing around 0.16 millisecond latency per lookup. Awesome. So all in all, we were able to build a fraud detection system that enriches data instantly using online feature store, scales automatically to handle traffic spikes, guarantees uptime, and monitors everything with auto capture in place. Let's also quickly go ahead and look at the other thing that we started. And here you go. So this was the notebook that we started earlier. As you can see, it started creating the same thing again, from data loading to data analysis to feature engineering, model training, evaluation, and so on. So basically, rather than starting from a scratch, Cortex code helps us, you know, build all of this in a very streamlined and fast manner. So in just a few minutes, we have built a banking grade fraud detection system that scales automatically, stays secure, and monitors itself, all without the data ever leaving Snowflake. The GA of online inference and feature store is a game changer for anyone building real-time applications. Head over to our documentation to start your first Stop the Swipe project. Thanks for watching, and we can't wait to see what you all build. Also, check out www.snowflake.com/ml to learn more about our latest ML capabilities. Thank you.